Yeah, so I'm going to go through talking about climate change really through the lens of climate risk. I've got a nice picture here from the New South Wales drought, so it's really front in mind for primary producers, just that intersection between natural variability but a changing climate as well. So I think I've done this right, I'm not sure.
It's the big green button on that one. Yep.
This one?
Yep.
There you go. So this is my only non-climate-y slide. It's from the World Economic Forum's Global Climate Risk Report 2018. There's some esteemed speakers coming after me that will talk about implications for the finance sector and economy. But it's worth just starting the talk looking at what a multi-stakeholder community surveyed by the World Economic Forum thinks about climate change in terms of all the risks that are faced by the global financial system. And 10 years ago, you would have seen cybersecurity and global financial crisis and a range of other things populating this list. When you look down both the likelihood and the impact of the top 10 risks identified internationally, climate change is now front and centre right through that list. So either as a direct physical risk from the changing climate itself, or as a threat multiplier or an integrated risk in terms of what it means for the rest of the global economy to have to shift to account for that. So when we're looking at impact, weapons of mass destruction is still number one, but following that is extreme weather events, following that is natural disasters, following that is failure of climate change mitigation and adaptation, following that is water crises. Cyber attacks, long bow to draw climate change on that one, but food crises, biodiversity loss, even large-scale involuntary migration will be influenced by climate change. So, the Syrian drought caused a large migration of people from rural to urban areas, intensifying conflict, for example. In terms of the likelihood, there's just one to draw your attention to there out of all of them, and that's 5, the likelihood of failure of climate change and mitigation and adaptation. And that's quite depressing that we're now counting that we will fail to actually account for the impact of climate change properly. And so we will be dealing with those risks, which means adaptation, and that's really what my talk is around today. So this is a little picture of what a failure to properly deal with climate risk looks like. So at the start of last year, Cape Town and South Africa in general was facing a water crisis. So Cape Town was facing day zero, which was the prospect of running out of water into 2018. That's partly driven by climate. Obviously, there's other issues there. There's management of the water supply. There's increasing population. But you can see there, the graph is of the dam levels in the Western Cape water supply system, which is 6 large dams. And you can see it going down year on year into 2018. The Waterskloof Dam, which is the biggest of the dams, is the middle picture on the left there. And that's what it looked like at the start of 2018. There's normally water in there, obviously. So how do we mitigate against this risk? The solution there was to actually ration water. So Cape Town residents were lining up for 15 to 20 litres a day, which is obviously something no jurisdiction in Australia wants to see. No Premier wants to see that. No city manager wants to see that. So I'm going to come back to what is a reasonably good story in Australia on managing water resources, but just have this picture in your mind, I guess, going forward. So what are the changes that are occurring now? So I've got a list here of changes in the climate system that basically require immediate investment in terms of building resilience to those changes. So it's not about waiting or kicking the can down the road or looking at the horizon. It's about investing in the changes that are occurring now or starting the investment in things that are going to take long enough to develop such that they're ready by the middle of this century. So increased frequency of large-scale heat waves and record high temperatures is the top of that list. Heat waves are the largest killer in terms of natural disasters in Australia. They account for more deaths than any other phenomena, largely down to about 10 events, but it's those type of events that we're getting more of and we're going to get more of into the future. A longer fire season with more extreme fire danger days. So that's obviously front and centre this summer, as it has been for many summers. We're getting a longer fire season, so pushing further into spring and autumn. We're getting more fire weather during that season, and the severity of the fire weather, so the most extreme fire weather days, are getting more extreme. That's having a range of other knock-on effects, such as reducing the time that we have for fuel reduction, And then for agriculture, things like smoke taint for viticulture is an issue. So we have squeezing off our management of fire from multiple directions, including climate change. Prolonged high ocean temperatures. So the most obvious impact of that was back-to-back bleaching on the Great Barrier Reef. So across 2 years, we lost about 70% of the reef recently in terms of mortality due to the bleaching. Some of that will recover, some of it will recover differently, so a different ecosystem to what's there now. Less reported is large changes off Eastern Australia in general. So the Tasman Sea is warming up the most in terms of temperatures around Australia. That is impacting on commercial fisheries and fish species and a range of other things. A very topical one obviously is reduced average rainfall and more time spent in drought. So that's a clear projection in terms of what Australia is facing in the future. So drought is a normal part of the Australian environment. It's perhaps a defining part of the Australian climate. But as temperatures rise and as rainfall patterns shifts, we expect to spend more time in drought into the future. And then against that, we have an increase in heavy rainfall. So even in regions where average rainfall will go down, the change in the warmth in the atmosphere and the oceans means that sub-daily rainfall, so there's really heavy rainfall events like has occurred in Townsville recently, are likely to be heavier than in the past. And obviously that introduces a whole range of risks across the Australian economy. And then the big one there is increased frequency of coastal storm surge inundation. For infrastructure in Australia, and in terms of the time it takes to build defences to sea level to make sure that you're actually provisioning resilience around the coast, that's probably the biggest single thing that Australia will face going forward into the 21st century. So coming back to water security and drought, dry lake beds is obviously something that isn't unfamiliar to Australia. So this is a picture from Lake Hume in the middle of the Millennium Drought, so towards the end of the Millennium Drought, 2007. I could have chosen the Thompson Dam in Victoria or a range of other water resources, water dams across the southeast. Just want to highlight here, there's two major initiatives. So in terms of the science around climate change in Australia, the question was largely around water availability and water resources. So we have quite a lot of science backing policy decisions in that space. And I've just highlighted two major research initiatives. One's the Indian Ocean Climate Initiative between the WA government, BOM and CSIRO, that kicked off in 1998. The other one's SEACI, which is the South East Australian Climate Initiative, which was a multi-stakeholder research project that kicked off in 2005. So when we look at rainfall changes, so as detailed in our State of the Climate Report, Southern Australia is drying, in common with South Africa, in common with Chile and Mediterranean climates in the Northern Hemisphere, so California, the Mediterranean itself. We're getting reduced rainfall. The rainfall, so that the high pressure band that sits over that part of the world is intensifying, and it's pushing the rainfall in our part of the world further south. So on the left there is, the top graph is the southwest WA rainfall, very similar plot to what you see for South Africa, in fact. And the dark line there, you can see the rainfall decline, so you're losing your heavy rainfall years prior to 1970, and then we kind of shift down into a new average rainfall regime after that period. And it was in 1997, so the black line is when that IOC partnership got going, and it took about 3 years for that research to flow through to policy decisions. I really would like to highlight that in terms of us going forward and managing our climate risk. There is still a pipeline between getting the research done and it having and informing decisions. It's not like we have a lot of things on the shelf that we can just spin up to inform climate risk at this point. And in the southeast, there's a bit more variability in the rainfall, but if you're good at looking at graphs, you can see there's also a shift in average rainfall that occurred about 1995 in the southeast due to the same mechanism, less rainfall from the cold fronts and cut-off lows that come over that part of the world. And again, in 2005, we kicked off the SEACI partnership, and it took a few years for that to flow through to support decisions, and mainly that was in terms of desal plants. So water security that's decoupled from climate for Australia's major capital cities. A large investment, obviously, but if you consider all the risks on our water resources, so climate's one of them, Melbourne and Sydney with 7 million people or 8 million people is another one. At the end of the next severe drought with higher populations in those cities, this is infrastructure, obviously, that Australia needs. And the graph there is showing the rainfall that we've seen over the past 20 years. So you can see lowest on record for the southwest and many parts of the southeast. So just switching tempo a little bit, this is a graph of increasing extreme heat. What it is a count of the number of times the Australian national daily temperature. So we calculate the temperature for the continent every day back to 1910, and we can count how many times per year we reach the 99th percentile. So this is the top 1% of heat days by month for Australia. And hopefully you can see a trend in that data. In 2013, we had about 29 instances of where the national daily temperature hit that 99th percentile. And you can probably see as well, it took many decades to accumulate that number of heat days in the early part of the 20th century. So this is a huge shift for an organisation like the Bureau. You're not managing these extreme events once every decade. You're managing it every other year or multiple times in the single year. So here's some examples of what those days look like. I've got the Black Saturday heatwave, which is iconic obviously in the southeast. We broke a lot of heatwave records. Some of those have been recently broken this summer, just to highlight that change in frequency. We broke, records right across the southeast, culminating in that Black Saturday fire day itself. January 2013 was the most significant heatwave. It probably still is in some ways, although we gave it a push this year. As well, but over 70% of the continent recorded temperatures in excess of 42 during that 2-week period at the start of January, and we broke every sequential heat record from 1 day through to 1 month. So in terms of what that means for an agency like the Bureau or the firefighters, you probably have 80,000 firefighters on standby in New South Wales alone, but this is a multi-jurisdictional event. So we have, the forecasters are working day and night during this period, and again, happening once every decade is different to that happening every year or multiple times per year. So that's a change in management of risk right there. I've also included February 2017 just to diversify these events. This is one which really challenged the energy system. So we were close to having to rolling blackouts, so load shedding to keep the lights on in Sydney for this event, which means maybe some regional towns or places within Sydney faced a period without power to manage that event. And again, what that means for the grid going forward means that we have to account for that. Let's talk about worsening fire seasons. There's a lot of ways I could have presented this. This is a graph on the date of the start of the fire season on the south coast of New South Wales. And what it's saying is the fire season is now arriving about 100 days earlier. So that is well into, that's the start of spring. What does that mean? It means some of the fires, and I've listed some here, started burning at periods on the shoulder season where our aerial firefighting assets weren't here. We co-share them with North America, so that's obviously a big provision in terms of climate risk on how you maintain those assets here for a longer fire season, and in North America they're doing the same, so they have a longer fire season as well, which is why I've got the ranch fire in California down there. And every state now, every jurisdiction has experienced one of these events which really rams home the impact of higher temperatures and drought and climate change itself. And Queensland, of course, was the last state to really get an event like that, and that happened at the end of November and the start of December on the central and northern coast there into Cairns, where you had temperatures in the mid-40s along the coast in that part of the world. I wouldn't have liked to have been there. It's very different to a mid-40s in Canberra or in Adelaide or Melbourne, for example. So I'm just going to, in the time I've got left, just talk a little bit to the recent conditions, the drought itself. Just highlighting January, so we talked about January 2013. The graph on the right shows where January 2019 came in, so you can see that big leap. So it's a fair way above that previous record in 2013, and it's these great excursions above the previous records that are the most impactful in terms of the thresholds that we've adapted, either our built systems or the natural environment's been adapted. It's when you push beyond those that you start to see things like a complete absence of water in systems that normally do have it, or fire in old-growth forests that are wet and don't normally burn. So that's a graph, a graph of the temperature in its historical context, and the spread of those temperatures you can see on the right on the map. So the orange there are the highest on record over January. Adelaide, the official record wasn't as high in the place that it's located now, but Kent Town, one of the older sites, nearly got up to 48 for a capital city. Again, if you're emergency services managing climate risk, the prospect of going towards 50 for a capital city means a lot of things for the infrastructure that we rely on. If you look at the rainfall deciles for the drought, it's really the last 24 months that are important. It's not just what happened in 2018. So what we've got is April to September, just that period, rainfall over 2017 and 2018. And so you can see most of the drought-affected parts of Queensland and New South Wales are well described by the rainfall deficiencies over that period. So this is a historically significant drought. You have to go back to the mid-60s to see droughts with a similar footprint. And it's up there with iconic droughts such as the World War II drought and, of course, the Federation drought, which is still probably the most significant dry period on record for Australia. But there is a difference, and the difference is due to climate change and the temperatures. So even compared to the Millennium Drought, this is by far the hottest drought that we've experienced in Australia. And you can see the temperatures over that February to February period. So New South Wales, which has suffered particularly, highest on record temperatures over quite a long period. So we're really drying out the environment further by having high maximum temperatures in particular. And we know that as we start to dry out the landscape, the importance of the temperature starts to go up in terms of the water availability and the moisture and the evapotranspiration. It's a bit different if it's wet and you're getting those high temperatures, but as it starts to dry out, you get a feedback between the lack of moisture and the temperatures that's really exacerbating. I'll finish there.